Okay, so here is our final project for EDL. We have all the flex sensors taped underneath here. We have our ATtiny right here. So in the back, we have the Arduino that we're using to do the data analysis and through this amplifier onto this speaker. There's also an SD card that we have right here that's preloaded with 30 phrases. And then on the bottom, we have the battery pack right there. Okay, so Jeremy can go through a couple phrases right now.
That sounds great.
There's one.
Nice to meet you.
There's two. Yeah, so a lot of these...
Hello.
Okay, yeah, so we'll do more phrases. It's kind of hard to do all the phrases with the glove on the hand, so we're going to take it off and then demonstrate more phrases after this. Here's our finished circuit. It's not on a person right now because it's easier to test this way, but the blinking light means that it's in the standby state. When I hit the button, it'll go to the listening state and the light will turn off. If I hit it again, the light will come back on as it goes back to the standby state. So this matches our design objectives of having a button that turns it on and basically turns it off. So most of the programming here is done through this ATtiny chip. What happens is there are 5 flex sensors all along this edge and a reference flex sensor right here, and 2 other resistors right here. So what these form is a bridge circuit, and if the voltage drop between the flex sensor and the reference is greater than the voltage drop between these 2 resistors, then the op-amp right next to it outputs a 1, which the ATtiny then reads. There's another part of this, which is these multiplexers. So these multiplexers shift whatever the inputs are, or they're basically switches to whatever the inputs are for the op-amp. So when the multiplexer switches to, say, flex sensor 1, the ATtiny records the number of readings that come out of flex sensor 1 such that the output of the op-amp is high. And if the op-amp is high for long enough, then it outputs another signal, which goes through one of these wires, to the Arduino. So in the Arduino, it reads the signal and then plays a phrase that's from the SD card on the speakers. So that's how the whole circuit works. So now we're going to go through and test every finger to show that we have 30 phrases that we can play.
Excuse me. That sounds great. Where's the bathroom? Could you repeat that, please? How does that sound?
You're probably going to need help.
Excuse me. What do you think?
Just keep yours going, yeah.
Where's the bathroom? I really appreciate that. Excuse me. Excuse me. Be careful. I don't understand. That sounds great. What's your phone number? That's a good deal. Hello. Where's the bathroom? I'm sorry to hear that. I'm sorry.
And do this one.
Please take me to this address. I'm starving.
There we go.
Yep, there we go.
What do you think? Where are you from? Excuse me. Where's the bathroom? I'm sorry to hear that. What are you doing to my squad? I'm sorry to hear that. Where's the bathroom? Oh, never mind. Excuse me. I'm exhausted.
Okay.
Now.
Excuse me. I'll be with you in a moment.
Okay.
And then.
What do you think? Where are you from? What do you think?
And then just all 5. Cool.
Yep, so we made all 5 be like, that would be like a fist. We made that also be a state where it doesn't output any audio in case you want to close your hand while using it.
How does that sound? Nice to meet you.
Index, middle thumb.
That sounds great. No problem. Please take me to this
Yeah.
address. That's a ripoff.
There we go.
Mm-hmm.
Hold on.
Help!
There we
There we
go.
go.
Pinky.
I'm cold.
Mhm.
Ah!
There it is.